Okay, ladies and gentlemen, good morning, good afternoon, good evening, wherever you are, and welcome to the second session of the third IRENA Innovation Week. This has become a major biennial event for IRENA, and this year the focus is on the use of renewables in industry and transport. My name is Martina Lyons, and I'm from the International Renewable Energy Agency, and it is my pleasure to be your host and walk you through today's session. In a moment, I will give you an overview of the session, but first, it is my pleasure to introduce you to Dr. Dolf Gieland, IRENA's Innovation and Technology Center Director, who will give his welcoming remarks. Dolf, over to you.
Thank you very much, Martina, and welcome everyone to this session. Thank you for joining this third IRENA Innovation Week. This one is different from the previous two Innovation Weeks because it's online due to circumstances. The previous Innovation Week in 2018 focused on power system flexibility, integration of solar and wind, and this time we will focus on end-use sectors and sector coupling. The world is facing an energy transition. Indicators are everywhere, from new wind turbines and solar panels to electric cars and low oil prices. However, we need to accelerate energy transition 4- to 5-fold if we want to stay within the Paris climate objectives. More and more countries are subscribing to the ambitious goal of decarbonization by 2050 or 2060, and while the objective is clear, the path to get there is not so clear, especially for hard to decarbonize sectors, transport and industry, where technology innovation is key. These sectors are at the core of our discussions this week. Sector coupling based on electrification and green hydrogen is a core part of these discussions, as is the use of biomass for energy and feedstocks. IRENA Innovation Week is part of a growing IRENA program of work focused on end-use sectors. This week's discussions build on inputs such as our annual Global Renewables Outlook, published in April, and our Reaching Zero with Renewables report launched 21st September. Insights from the discussions this week will inform our further work, including the next edition of Global Outlook in Spring 21. We also work with partners to ensure those insights inform key climate discussions in preparation for COP26 in November 21. So, IRENA Innovation Week will provide essential inputs for the global debate on 1.5 degrees scenarios and pathways. During this Innovation Week, we have 6 sessions over 4 days. We want to inspire and inform decision makers by showing what's possible. We will showcase innovative solutions from around the world that can help to deliver deep decarbonization in industry and transport, and we will bring together innovative companies, researchers and policymakers to explore what is being done and what we need to focus more effort on. If you want to join other sessions, you can register online. All sessions are open for participation. You will receive the link and details. We want your input into the session because the dialogue is essential. You can ask questions through the chat function. Time allowing, moderators will try to include your questions into the panel debates. But to also use the chat function to share your reactions to what you are hearing or insights from your own work. We'll capture all feedback and utilize it in the next phase of analysis and engagement on this topic. I hope for a fruitful and engaging dialogue. Thank you for your attention. This concludes my opening remarks.
Thank you, Dolf. Well, as Dolf mentioned, under normal circumstances, we would have met in person, as was the case in 2016 and 2018 IRENA Innovation Weeks editions. But having a virtual event has its benefits too. We can connect from anywhere in the world. In fact, we have over 200 registered attendees from 2,000 registered attendees from 146 different countries. Our speakers also come from many different continents, and they are ready to showcase their experiences and emerging innovative solutions that can fully unlock renewables potential in industry and transport sectors. So today's session focuses on one aspect of a supply side, that is industry and transport sectors transition. It's entitled Smart Electrification of End-Use Sectors and its Implication for the Power System. As mentioned, IRENA is organizing this session in partnership with the Electric Power Research Institute, EPRI, which is a Washington, D.C. based nonprofit organization that conducts research, development, and demonstration projects in the field of electricity generation, delivery, and everything beyond that. The aim of today's session is therefore to explore its implication for the power system of massive electrification of the transport and industry sectors, and discuss which smart strategies are key to harness the benefits of coupling these sectors. Let me just go quickly through today's agendas. So, as we heard, Dolf Gillen from IRENA has already welcomed you all. Up next will be Francisco Boschel from IRENA, who will set the scenes for following panel discussions. Then we will have 4 panel discussions, 3 global perspectives on the electrification trends and challenges, impacts of electrification on distribution system operators. Then we will discuss impacts on electrification on transmission system operators, and at the end, we will have a joint perspective of all actors. And in the closing remark, Robert Chapman from EPRI will briefly recap and wrap up the session with his key takeaways. So without any further ado, let's move right to the scene setting part. It is my pleasure to introduce you to Mr. Francisco Boschel, IRENA's lead analyst on renewable technology markets and standards, who will bring IRENA's perspective and set the scene for the following discussions. Francisco, over to you.
Thank you very much, Martina. Let's move to the next slide, please. Yes, so as Dolf has mentioned, and as some of you may remember, the previous IRENA Innovation Week focused on integrating high shares of low-cost variable renewables in power systems. As we can see on the slide, to achieve the Paris Agreement objectives, we will need to increase the share of wind and PV in global electricity generation from 10% at present to more than 60% by the mid of the century. The good news is that for more and more countries, they are reaching higher shares of variable renewables. For example, during the first semester of this year, the pandemic period, the share of renewables, mostly variable, in total power generation in Europe was more than 40% on average, a share 16% higher compared to 2019. And those experiences are showcasing many innovations that are replicable in other countries. Next slide, please. And as a result of the previous innovation weeks, IRENA has published its Innovation Landscape Report, which is a toolbox of 30 concrete innovations that can support countries in integrating very high shares of variable renewables in power systems. On the slide, you can see the 30 innovations elaborated in the toolbox, which cover not only technology, but also innovations in business models, market design, and system operation. And one relevant group of innovations framed in red on the slide are focused on the electrification of end-use sector. Next slide, please. And our analysis indicates that as renewable electricity is becoming the most competitive generation option, then electricity will be a key energy vector to decarbonize end-use sectors, particularly transport and industry sectors. As shown on the slide, today, only 20% of global energy demand is met by electricity. However, we expect that by the mid of the century, that share will increase to close to 50%, propelled by a mass deployment of technologies such as electric vehicles, heat pumps, and electrolyzers for hydrogen production. In terms of investments, we expect that this trend will result in more than 20% of all energy-related investments going to electrification technologies and power systems infrastructure, with $27 trillion cumulative between now and 2050, or $800 billion per year, as shown on the figure on the right side. And to put it in context, that's about 3 times what is invested nowadays in annual additional renewable energy generation capacity, which is around $300 billion per year. So that's the magnitude of the investments we need to see on electrification. In addition to the investment perspective, the electrification trend will also have a system integration aspect to be considered. The next slide, please. And on this slide, what we have is the case of charging electric vehicles. The column in red shows the results from several studies, including IRENA, on the increase on peak demand in distribution systems due to charging electric vehicles in an uncontrolled manner. And the column in green shows the increase in peak demand in a controlled manner, which is, as you can see from the numbers, significantly lower than in the red column. It's clear that uncontrolled charging will result in a major constraint and additional cost to reinforce electricity grids, which in some cases may even completely block the rollout of electric vehicles. Then it is great to have smart technologies like digital technologies, electric vehicles, heat pump, etc. But we also need to use those technologies in a smart way. And our definition of a smart electrification is an approach that adapts the performance and load profile of those electrification technologies to meet the needs of consumers, but also the needs and considerations of the electricity system. Next slide, please. And this slide shows how a smart approach to electrification, as mentioned previously, requires enabling and smart technologies like digital technologies, blockchain, artificial intelligence, electric vehicles, stationary batteries. But it also needs innovative business models like aggregators, new market design, such as new ancillary services markets, and innovative system operation, for example, enhancing cooperation between transmission and distribution system operators. And this is what we call in IRENA the systemic innovation approach for a smart electrification. So electrification in a not intelligent way would be quite problematic, but electrification in a smart way would decarbonize end-use sectors while making power systems even more renewable. Along this session, we will discuss with our distinguished expert panelists on how to design and implement such smart electrification strategies tailored to country needs. Next slide, please. Those of you who have been involved in previous innovation weeks already know that this is not a one-shot event. Also, Dolph mentioned that this is a process. And all the feedback and the network of experts created at this event will be input to our forthcoming work to support countries in their energy transition. Particularly, your input will be used for this year's publication on the best practices for electrification of end-use sector, and the next year we will publish our second innovation landscape report, which will provide a new toolbox for countries to design smart electrification strategies. So we invite all of you to approach us if you would like to be informed, but also engage in the process of developing those products. Thank you so much for your attention, and back to you, Martina.
Thank you very much, Francisco, for setting the scenes for our upcoming discussions and for sharing with us tremendous progress made by the power sector in the last few years, and the role of systemic innovation in it, which cannot be stressed enough, and which will play a major role in smartly electrifying the end-use sector. So thank you very much. Francisco will be our moderator of our first panel discussion on the global perspective. But before I hand over it back to Francisco, please don't forget to use Q&A feature to ask questions to our speakers. And now, Francisco, back to you.
Thanks, Martina. Now I'm delighted to introduce to you our expert panelists for our panel on global experiences in electrification of end-use sector. We have with us Mr. Rob Chapman, Vice President of Electrification and Sustainable Energy Strategy at the Electric Power Research Institute from the US, EPRI. Then we have Mr. Christian Ruby, Secretary General of the Union of Electricity Industry in Europe, Eurelectric. And we are also very happy to have Dr. Koshichi Namoto, Vice President of the Central Research Institute of Electric Power Industry of Japan, who is actually connecting now from Tokyo, where it's around 1:15 a.m. So we really appreciate that you connect with us at this very late hour for you. Our panelists will give us now an overview on the key trends and good practices to electrify the transport and industry sector in the US, Europe, and Japan. So now let me start by asking the three of you the same first question. So as we have been discussing, electrification is a major trend to help us to decarbonize the end-use sector, and if done in a smart way, to also decarbonize even the electricity sector, or make it more renewable. So we would like to hear from you, what are the electrification targets, trends, and strategies pursued in your respective geography? Which sectors do you see that are at the forefront and which are lagging behind? So let me start with Rob and the US perspective. Rob?
Great, thanks, Francisco, and I'd like to thank IRENA for the opportunity to work with them on this particular virtual workshop in this particular session, and welcome from California to all of our participants. Francisco, I wanted to mention 3 areas that are primary focus in the U.S. and I think very consistent for others, but the focus is around our transport sector, of course, and what we can expect to achieve from electrification of transport. I'll then talk briefly about buildings and industry. But of course, what is fundamental in being able to electrify end use is what's been going on in terms of greening of the supply. The fact that the U.S., the carbon footprint of the utility electricity sector is now lower than our transportation sector affords us the opportunity to take this clean fuel that is now being produced in the electricity sector, or cleaner fuel, and apply it to other end uses. So where we see specific opportunities going forward really are around the transport sector. And because of the fact that we see the economic total cost of operation of electric transport being at or equivalent to that of internal combustion engines. That, of course, is due to battery costs that have been trending down substantially. That has really enabled the cost of these vehicles to reach that total cost of operation parity. I think the other thing that's very important to recognize is we might have technical and economic potential identified, but the achievable potential, what a consumer will actually adopt, is also progressing very rapidly based upon the number of models that are now available. In the U.S. market sector around transportation, 66% of the consumer preferences are focused on either buying a sport utility vehicle, an SUV, or a small light-duty pickup truck. And what we are seeing now is the OEMs being able to deliver on those models and make sure that they are available for consumers to make that choice. The other thing I want to emphasize around transport is we are seeing fleet operators and public transit very quickly beginning to adopt electric transportation technologies. Fleet operators, primarily example would be Amazon, very focused on their sustainability objectives and obviously the impact of their fleet vehicles today on achieving that. They're progressing very quickly and enabling the opportunity to support a much quicker transition, perhaps in the fleet side of the house. Public transit, same thing, by and large driven by the need to not only reduce carbon footprints, but also improve air quality. So transport is the area that we see as the greatest near-term opportunity, but buildings also offers a significant potential for us going forward. It is more challenging, especially when we look at existing stock of buildings and how do we go about retrofitting those, especially in urban environments. And yet we are looking at some favorable policies within certain regions of the U.S. that in new construction are driving net zero energy homes, and that is helping to support a transition within the building sector. And finally, in industry, we like to reference the direct electrification of end use versus the indirect electrification of end use. And Francisco mentioned this, the importance of hydrogen and establishing that technology to support some of our larger industrial customers that have a significant amount of energy use. So Francisco, let me turn it back to you. That just is a brief overview on the areas of focus from the US in terms of end use electrification.
Thank you so much, Rob. A very insightful perspective from the US, highlighting the importance of also looking at the economics, the total cost, for example, the total cost of ownership for electric vehicles. Also the importance of, with this electrification, engage the consumers and attract the consumers with their own preferences. And in the case of US, you mentioned the importance of addressing the vehicle segment with, for example, SUVs or pickup trucks, which is one of the main preferred trends in the US for road vehicles. And also very important, the issue about retrofitting buildings, which is not just a technological aspect, but it's an urban planning aspect as well, very important to consider. So we see the nexus between electricity, but also urban planning. electricity planning and urban planning, and also highlighting the importance of indirect electrification for industry. So very, very good points, well taken, Rob, and we are happy to see the progress in the US. And now I would like to move to Europe. So Christian, what is your perspective from Europe on how this electrification trend is advancing and what can we see in the next 5-10 years happening in Europe?
Thank you, Francisco. So essentially, what's really encouraging in Europe is that everybody literally agrees that doubling down on decarbonization means doubling up on electricity. And what that means is that going to net zero by 2050 will require us to reach those levels of direct electrification that you mentioned earlier in your intervention. We're looking at ballpark figures of 50 to 60% of total final energy consumption. And that's, mind you, up from around 22 to 25 today. So we're really looking at a major journey, a major build out of the power sector. On the one hand with renewables, and on the other hand on the end-use sector side, a major electrification in order to absorb that clean electricity. Otherwise, we're going to have a collapse in prices. So the good news, as I said, is that this is literally shared by everybody in this space, and that means that we're now looking at a policy work with the Commission and the stakeholders to make this a reality. And looking at the big end-use sectors, I would say that both buildings and industry have, relatively speaking, high levels of electrification in buildings due to the cooling systems, electricity used for lights, appliances, and so on and so forth. In industry, we see some use of electricity there, for instance, in aluminium and other major electricity using sectors. The big challenge right now is transport. The big challenge and the big opportunity, I should say. Only around 1 to 2% of the energy consumption in transport is electric today, and we need to bring that up in ballpark figures of 60 to 66% over the next 30 years. So we have a bit of time, but looking just 10 years ahead, we are talking about at least 40 million electric cars on the roads in Europe. Which is needed to get there, and also advanced electrification of some of the heavier segments. So Rob was mentioning some of the positive developments in public transport, for example. We're seeing the same trend in Europe, and we're seeing literally almost every day new, very encouraging signs. Just recently, Belgium, where the European Union has its headquarters, announced a policy that by 2026, all cars owned by company cars should be electric. We've just seen in Norway the most recent sales stats that 4 out of 5 cars are now electric or hybrid, and 3 out of 5 cars are all electric. So we're seeing in some countries really this change take off. Now the challenges remain how to make sure that we also see that development where the market is not driving it. We have parts of Europe that has a big second-hand market for cars, and of course it's more difficult to put up a charging point there and expect that you still have a good business case. So we need to see the policymakers come with a plan for how we see a full adoption and a full rollout of the infrastructure in transport. Here at the end, just a quick word on buildings. Buildings is a place where electrification is really closely connected with the renovation rate, and we need to double or even triple the renovation rate in order to reach the necessary electrification here. There's a big program in Europe going on where as part of the Building Back Better and responding to the economic crisis triggered by Corona, that the governments want to invest in buildings and renovation. And we're saying here, this is the time to electrify. This is the time to equip buildings with solar panels, heat pumps, and the necessary charging infrastructure. So this can be a huge leap forward, but it's also challenging. We know that. Back to you.
Thank you, Christian. Very interesting perspective from Europe, and some very important points that you made in your intervention. For example, the importance of electrification going hand to hand with a massive upscale of renewable electricity, which sometimes is actually forgotten. So it's important. Electrification for decarbonization only makes sense if you have a low carbon generation source, and I think that this is an important message. Also interesting to hear from you that you think that the main challenge in Europe is the transport sector, and especially the, let's say, the heavy duty segments. And I think that we will have some discussions across the Innovation Week on that, but as you said, there is no really clarity yet on what would be the best approach for those sectors, direct, indirect electrification. So definitely is something that is still to be seen. Very encouraging to see some countries, as you mentioned, Belgium, for example, setting already targets to have at least company cars all electric very soon, because that's the pool that would actually also accelerate the learning curve and bring and scale up the market. And the point on infrastructure is crucial, I think. And I think policy making, as you said, is definitive in let's say, directing the investments into the right infrastructure, not the old infrastructure, but the infrastructure of the future to be prepared for a massive electrification. Also, as you mentioned, Europe targeting for a 60% of electrification rate by mid of the century, even higher than what we think would be the global average, is very ambitious and encouraging. So thank you so much, Christian, and we will come back to you with a few follow-up questions on these points. But now I would like to move to Dr. Nemoto. So, Dr. Nemoto, from the Japanese perspective, how do you see this electrification of end-use sector trend moving forward in the case of Japan?
It is my honor to be part of this panel. At first, in Japan, the most electrification progressing areas are the residential sector and the business sector. In 2018, the electrification rates are more than 50%. Next is the industrial sector with 24%, and lastly, the transportation sector with the lowest electrification rate of only a few percent. The overall electrification rate in the final demand would be about 26%. And in Japan, the biggest trend of electrification is residential electrification, especially all electrified house. Annual sales of all electrified houses are about 300,000 units. An important thing is that all electrified house is zero emission ready. In Japan, the climate is warm and fossil fuel consumption for heating is low. And home electric appliances are widely used. That is why the electrification rate of the residential and the business sectors are high in Japan. Important device is a CO2 refrigerant heat pump hot water supply equipped with hot water reservoir tank. Japanese people love taking a bath very much, so the demand for hot water is great. This is an effective device for utilization of surplus power from solar cells. In addition, net zero energy house and net zero energy buildings are realistic technologies, although the costs are high at present. These will proceed in terms of energy conservation, decarbonization, resilience, and also be pushed by national energy regulations and financial support. In Japan, the Great East Japan earthquake in 2011 damaged large power sources, resulting in a severe power shortage. Rolling blackouts in eastern Japan, including Tokyo, had a strong impact to us. For this reason, energy measures in Japan have mainly focused on securing power sources, saving electricity and saving energy, and of course, decarbonization and renewable energy. But electrification was positioned as a means of energy saving. However, the situation has changed in the last few years. And this year, the revision of the strategic energy plan is scheduled to begin. It is being paid attention to whether the electrification strategy will be clearly incorporated in that strategic energy plan. It is desirable to clarify the promotion of electrification in terms of policy in order to clarify Japanese decarbonization strategy. This is my comment. Thank you.
Thank you very much, Nemoto-san. Very interesting also to hear from the Japanese perspective that, for example, there is still quite some opportunity to increase the share of electricity, for example, in the transport sector and in other sectors. But however, Japan already reached a 26% of electrification rate in total energy demand, which is higher than the global average. Also, as you mentioned, the importance of continuing to reduce the cost of those technologies related to electrification, not only electric vehicles, but heat pumps as well, to make them attractive. And very important that the electrification and renewables rate should go hand in hand with energy efficiency programs. And that's a very important point, definitely, because without energy efficiency, the whole system would just end up in possibly a higher system cost and not the most effective and optimized way to electrify and use renewables. And for that, as you said, the energy planning aspect is crucial. So very interesting to hear from Japan those aspects. And now I would like to have, I think we have a little bit of time to quickly go back to a few of the follow-up questions. So first for Christian. As representative of the electricity industry sector in Europe, are you already seeing that the electricity industry is having a dialogue with, for example, the automobile sector, the industry sector, as you said, to have these infrastructure, big infrastructure programs together, considering the supply and demand aspects? Is this happening in Europe at the moment?
It is happening both at the individual company level, also through the national associations, and not least in Brussels, where we have created an alliance for all the electricity producing sectors, along with the copper industry, the electric car industry, and other end-use sectors. We also work closely with the Car Manufacturing Association to basically align on standards and all this. But I would say we need an even closer dialogue, and we need more of the dialogue. There are still people that are not part of this equation yet. If we look at the thousands and thousands of buildings out there in Europe where people live, that need to have charging points in front of them in order for people to be able to charge their cars when they come home at night. We need to get the building owners into this equation much more. We need to get the local authorities into this equation. We need to get the supermarkets. It's happening, but we need to be aware that we're talking about an exponential trend. It's not something linear where we have a little bit of time all the time. We really need to scale at a pace that we haven't tried before.
Thanks, Christian. Indeed, also engagement with all stakeholders, consumers, industry is important. Good to see that it's already starting to happen in Europe, and hope this continues. And coming back to you, Nemoto-san, we know that Japan is in the process of liberalizing its electricity market. And since 2016, actually, the retail market is liberalized, which opens the opportunity for end users to be more active actors in the power system, and also more opportunities for demand side management and so on. Do you see that in the case of Japan, this move to a liberalized retail market is already attracting end users to be more active and also engage, for example, in electromobility, heat pumps, and so on? What is your perspective on that?
Yes, thank you. As you know, after we have full liberalization in 2016, and after that, for consumer, the options of suppliers and the services have increased. The switching rate of suppliers and the services has been estimated to be 24% as of April last year, since 2016. The share of newly entering power company has reached more than 16%, and it is evaluated that the power system reform is effective. Moreover, there are already opened several markets, wholesale electricity, base load power supply, and capacity market. In the future, the supply and demand adjustment market is scheduled to open in 2021. So several trials have begun on the aggregation business that utilize electric vehicles in virtual power plant. However, in 1920, in Japan, more than 100,000 private electric vehicles are widespread. However, it is only less than 1% of the number of passenger cars. So that is a problem. In addition, demand response participation of consumer equipment such as electric furnace in the industry sector is also expected. On the other hand, the rooftop solar cell system expired of feed-in tariff has been more than 2 million kilowatts since last year. Retail company can buy and use them as its own power sources. Also, self-consumption of electric power by heat pump is very cost-effective for consumers. I think that various services related to rooftop solar cell will come out. And on the other hand, there are many typhoons and earthquakes in Japan. So there is a high level of interest in resilience, especially after the Great East Japan earthquake. So in many detached houses, rooftop solar cells and batteries are being installed, and the self-consumption is increasing. Household fuel cells are also becoming widespread. The so-called prosumer, prosumer in the residential sector is progressing. In Japan, resilience and decarbonization are accelerating this move. In the residential sector, dependency on grid power and large-scale power sources are decreasing. So I think in Japan, there are two types of electrification. One is by grid power, and another is by self-consumption. I think these should be different in business and energy policy. Thank you.
Thank you, Nemoto-san. Very interesting to see how the consumer is becoming actually more engaged in the Japanese market as well with the prosumers, as you said, and demand response. Still a big challenge on electromobility, but it is expected that this will also improve. So finally, quickly, Rob, because we are running out of time, but I really want to hear from you about the engagement also of the end consumer through regulatory mechanisms, especially dynamic pricing. We see that in the US, different states are implementing different time of use tariffs or dynamic pricing to also generate more demand side management and so on. How do you see this trend in the US? Can we already extract some good practices from what we see in the US on that aspect?
Yes, thanks, Francisco, and I will be brief. Let me just make a few highlights. We do view dynamic pricing as a key enabler of affordability across all classes of customers. So very important in the U.S. In fact, one of the statistics we like to look at from a flexible load perspective, recognizing end-use electrification and distributed energy resources in general, flexible load is expected to increase by 80 gigawatts by 2030. Ultimately, we will have about 200 gigawatts of flexible load, or about 10% of our peak that we expect to be flexible in the United States by 2030. So in terms of influencing consumer behaviors, it's going to be a critical part of our solution. Right now, many of the utilities are using what we call time of use rates instead of dynamic pricing. The difference between a time of use rate and dynamic pricing, though, is significant. Typically, time of use rates only have a multiplier of about 1.5 times the cost for peak energy versus off-peak, whereas dynamic pricing, you have true price signals that put that differentiator at anywhere from 4 to 5 times the price of off-peak power to on-peak power. So through that economic lever, it is really driving different behaviors, and we have some very good examples in the United States and several of our utilities that have incorporated dynamic pricing into their overall pricing mechanisms and being able to really have a significant impact in terms of flexible load. I do think that the most important part part around dynamic pricing that we as an industry need to coalesce around is how do we explain it? How do we explain energy consumption, electricity consumption to the consumer in a way that makes sense to them? Right now, kilowatt hours probably are not the best way to communicate the impact of affordability and how they can manage their overall energy costs. So just very briefly, dynamic pricing, very critical in the US. Like I said, ultimately about 10% of our load we expect to be flexible by 2030. Being able to leverage that is a key part of the solution to ensure consumer affordability. Back to you, Francisco.
Brilliant. Thank you, Rob. And very good point on the importance of communicating and engaging with the end consumer in a way that is approachable to them and understandable to really act accordingly and see the benefits. Really, really insightful. Well, unfortunately, we have run out of time for this panel, but I want to express our gratitude to our three distinguished panelists, Rob, Dr. Nemoto, and Christian, for all your insightful opinions and comments during the session. And now I would like to hand it over back to Martina. Thank you.
Thank you, Francisco, and our distinguished speakers for sharing with us your views, your experience, and future plans from your corners of the world. Special thanks to Dr. Nemoto for staying up late in order to join us. You all kick off the session with an insightful discussion, which shows how the world is learning and doing all this. Thank you very much. And let's move to our next panel. So our next panel discussion focuses on DSO perspective. So we are going to now look at one of the power sector actors, and it is my pleasure to introduce you to our next moderator, Mr. Christian Ruby, who is the Secretary General from Electric. Please, Christian, over to you.
Thank you very much, and thank you for letting me host a session on a critical issue of the whole nexus between renewables, energy transition, decarbonization, and electrification, because with distribution grids, we're really at the heart of where all this will take place. We assess in Electric that around 70% of all the new power generation that we will see come to the grid in the next 10 years and probably longer will all be connected to the distribution grid. Whereas in the past, it was the transmission grid that had most of the connections. This is really changing with the decentralization of the system. As we discussed in the previous session, we also have the whole issue of electric cars and the charging, so the new load coming to the system. So in short, distribution grids are really at the center of this transition, and that means we need to see more investments in the grid. Electric is just currently creating a major study to assess the investment needs across the system. And in addition to the transition, we see a number of other drivers. Nemoto-san mentioned resilience as one, but we also see the need for a general modernization and digitization of the system. So the distribution grids are really a critical issue that deserve our attention in order to see how can we make this decarbonization and electrification a successful venture. So that's what we're going to discuss here today. In the previous session, you saw, you heard us talk about the general trends, the targets, where are we going, how far do we want to electrify. What we want to try to do in this session is to listen to some of the experts from the field, some of the people working on this every day. What are their successes? What are the obstacles and the challenges they're meeting, and what can be done to overcome these? And we have a very good panel, a good mixture of distribution system operators, of utility companies, and also of technology providers. With us here, we have Bastian Faher. He's the head of innovation management in Stromnetz Hamburg in Germany. And we have him on the screen. We also have Katie Sloan with us. She is the director of e-mobility and building electrification at Southern California Edison. So Katie, if you could turn on your camera. We also have with us Gregory Poilasne. I hope I pronounced that right. He's the co-founder and CEO of Nuve. That's a company that specializes in V2G technology, so vehicle-to-grid technology. He's going to explain more about what that is and how that works. And last but not least, we have Sandra Tritin, who's the co-founder, CSO of Tico Energy Solutions, which is a company providing a smart energy management platform that can act as a virtual power plant and provide many other types of services. So I hope we get our participants to join and see their cameras. Currently, I'm not seeing them, but I plug and pray that the other participants will join us in due time. Bastian, maybe to kick it over to you, it'd be interesting to hear a little bit about how you see this issue of electrification being really at one of those companies that are doing this in a big city, several million people up in Hamburg. What is your greatest achievement or success in the space of electrification?
Yes, thanks a lot, Christian. Hope you can see and hear me. Okay, perfect. Yes, thanks a lot to have the ability to talk in this panel. I want to give you a first idea about the company Stromnetz Hamburg. As a distribution system operator, we are responsible for nearly 30,000 kilometers of lines and cables, 55 substations, and 75,000 transformer stations. And we have more than 1 million customers in our distribution grid, and a peak load is actually about 1,800 megawatt. But we expect an increasing of this peak load up to 40% in the next 20 years. And this increase causes mainly by electric vehicles, heat pumps, and public transport sector. And as I said, we operate 7,500 transformer stations in Hamburg. Usually one of these stations supplies 300 to 450 households, depending on the transformer size. And the size is normally between 400 and 640 kilowatt. So actually we calculate 1.5 to 2 kV per household by a simultaneity factor of 1. And this was appropriate for the last decades. But now we have nearly 700,000 cars in Hamburg. And by the goals of our federal government, 100,000 of them will be fully electric vehicles in the next years. And we expect most of these vehicles will be loading at home. And when we accept 60,000 private wall boxes in our distribution grid, we will have critical situations at nearly 1,000 of our transformer substations. The cable or the transformer or both of them could cause a critical situation because overloading the asset. And this adoption is also by a simultaneity factor of 1. So we answered the question, how realistic is a simultaneity factor of 1 first, and we decided that it is sufficient realistic. Most of these 60,000 wall boxes will be used after work when the customers come home with their car. Our job as a distribution system operator is to reduce this simultaneity factor. When we reduce it down to 0.2, the number of transformer stations in a potential critical situation decrease down to 200. We implement measurement techniques in the transformer station to identify potential critical situations. We know then which infrastructure is responsible for critical situations. And now we can send the critical infrastructure an impulse to reduce the load. This system works completely automatically and forces to a load reduce of flexible infrastructure down to 25 to 50% to protect the grid. This is our case of control charging. Otherwise, we have to rebuild thousands of kilometers cables and lines and hundreds of transformers in the next years.
That's very interesting, Bastian. So basically, you're saying you've built a system that allows for smart charging and reduces the need for build out of physical assets. But taking into account the rise you mentioned from 700,000 cars, out of which 100,000 would be electric in a number of years' time, can you still manage the amount of cars with that system?
I think we buy us some time to rebuild the grid. It won't be useful for more than 100 or 200,000 electric cars in Hamburg, but it buy us some time, and I think it will work the next 10 years with the infrastructure we have now.
Thank you. And looking at, let's say, the biggest challenge or an obstacle that you have to face, what would you point to as the one?
Rebuilding lines and cables, and of course transformers, because in a metropolitan city it is very critical. Everybody is asking for construction sites and so on. It's very critical to get permissions, and it took a long time and cost lots of money.
So permitting as a key obstacle, essentially holding back the energy transition. This is something we can very much, let's say, subscribe to and recognize in Electric. It's something we hear from all the companies across Europe. Huge challenge. Thank you very much, Bastian. We'll be back to you in a second.
Thanks.
I'd like now to turn to Katie. So Katie is the director of electrification at a utility in California. Katie, hi.
Hello.
I read that you basically are on a mission to help the government of California introduce 7 million electric cars over the next decade and electrify up to a third of the building energy consumption. Is that correct?
That's correct.
That's a fascinating mission. Are you up for it?
Yeah, we're definitely up for it. And to even expand it further, by 2045, we're looking to get 26 million passenger vehicles on the road, and then 1 million medium and heavy duty vehicles. So it is quite a road we have in front of us, but we're definitely up to the challenge in California. You may have seen that just in the last couple of weeks, our governor announced that all new vehicle sales for passenger vehicles will be zero emissions by 2035. And for trucks and other larger vehicles, they'll be clean, zero emission by 2045. And those goals and requirements are right in line with what we need to achieve in California, and really will support our mission.
That's exciting. What is the biggest success or achievement of your company until now? Because we all have these enormous goals in front of us, 10%, 100% by 2035 or whatnot. On the ground right now, what's the progress and what are you most proud of?
Sure. I think a couple of different angles here. One is really the approval of investment that we'll be making. So the way that California electric utilities work, and for folks that aren't familiar with Southern California Edison, we serve about 15 million customers in a 50,000 square foot area. And we have to get approval by our California Public Utilities Commission in order to build out infrastructure for electric vehicle charging stations. And back in 2016, we were running one pilot that had approval for $22 million. We've run that. We've installed, between that and an expansion of that pilot, 2,500 ports. But today we have approval of $800 million that we can spend over the next 5 years on infrastructure investment. So that's already been approved. We're now just executing on all of that, which is its own challenge. And I think one of the successes that I've seen this year, which obviously has been challenging in so many different ways, is that we're still seeing a lot of good progress in a program that we call Charge Ready Transport, which is for medium and heavy duty vehicles, buses, port equipment, shuttles. And we have already secured applications for over 1,600 vehicles. And we met and are exceeding some of the internal goals that we had for that program, even in the midst of COVID. So for me, that's been a really exciting progress that we've had. And we're even looking at doing things virtually with that program. We've been able to continue with construction, virtual tours, virtual inspections, to keep that moving. So that's been some of our great progress that we've had.
Oh, that's exciting. It's very interesting you mentioned COVID because we've had exactly the same experience here in Europe, a little bit different depending on the region, but that many public construction projects were frozen. Access to the construction sites was prohibited, and people couldn't move around. So in addition to the Corona challenge, what would be the big ticket challenges that you're seeing standing in the way of success for electrification and decarbonization?
Mm-hmm. Yeah, a couple of the themes that we've started to pick up on this morning, I really think vehicle availability is very important. Having them at different price points and different models on the passenger vehicle side. And, I think the next 2 years are going to be really crucial to see if all the vehicle manufacturers are coming out with the trucks that they've been talking about. So I think we've seen some really good announcements for some of the work trucks, like in California and America, the Ford F-150 is a very, very popular work truck. So we're excited to see that that's been announced to be electric, and some of the semi vehicles that are coming out from automakers like Tesla, Volvo, Daimler. So I think that'll be a proof point. And also, as far as challenges, is making sure that fleet operators are really comfortable when we're talking about the medium and heavy duty side. They have to be comfortable that the maintenance is going to be lower and meet all those expectations, that the vehicles are really going to perform in the way that they're expected to perform, and that their drivers are comfortable with them. So I think that's really an area that we as a utility are doing our best to partner with our customers, partner with the automakers to provide tools and resources and training to make sure that people know that they're going to be getting what they expect.
Very interesting. Before I move on to Gregory, I'd be interested in hearing, we've all followed these terrible wildfires in California, and we heard Nemoto-san talk about the challenges for electricity system operators and utilities with such extreme weather. Is this something you can recognize also as a challenge from California?
I'm actually here at home after having been gone for a month because our family was blocks away from mandatory evacuations for wildfire. So this is impacting me both on a corporate level, but also a very personal one, and also with not just the fires but the air quality. So I think that for us as a company, this is really doubling down on our pathway for clean energy, doubling down on electrification, because these wildfires are getting worse because of climate change. And so for us, there's definitely that challenge of making sure that we're keeping the infrastructure hardened, making the right investments to avoid wildfires where we can. But really from a more macro perspective, it means that we have to go further and faster. So that means that in addition to the investments that we're going to be making to electrify, to clean the grid with renewable energy and battery storage, we're also going to need to be making investments in the actual grid that we already have.
Thank you very much, Katie. Gregory, over to you. So you are the founder and CEO of a company called Nuve. I hope I pronounced that right. And you specialize in vehicle-to-grid solutions. I'm sure everybody has heard about vehicle-to-grid, but can you educate us a little bit about how that exactly works and what's the business model here?
Sure, absolutely. Good morning, and thank you very much, Christian. It's a pleasure to be here today. So at Nuve, our mission is to help reducing the cost of ownership of electric vehicles while supporting the integration of renewable generations. On the one hand, you have the renewable trend, right, which is great from a CO2 perspective, but it's a very volatile generation. And so it requires storage in order to really be truly useful to society. And then on the other hand, you have electric vehicles that have big batteries and that park most of the time. And that's really where the concept of vehicle to grid started when Willett Kempton started to work on this in 1996. His vision was that with adding a little bit more power electronics, either inside the car or inside the charging station, then you would have the ability to not just take energy from the grid into the car, but also push energy back to the grid, which then would become a true storage solution on wheels. And so at Nuvve, we have a platform that is a virtual power plant that has the ability to aggregate electric vehicles that are over a large area, vehicles that would have V2G capabilities, meaning that can be bidirectional, or vehicles that are only unidirectional. We can also combine that with stationary storage. And then we're supporting a wide range of grid services, going from firming solar and wind on the generation side, participating to the wholesale market and ancillary services at the transmission level. And today, for the focus of discussion, really, supporting the distribution system through demand response program, also providing voltage control, reactive power, and then we can also help the customer optimize their bill from a time of use perspective and demand charge management. So for us, right, the true definition of vehicle to grid is not just about the bidirectional capabilities, right? It's really about transforming electric vehicles that are inherently heavy loads at the end of the distribution system, but they are also unreliable because at any time somebody might come and unplug the vehicle. And so if you can go on the next page, sorry. And so our goal is really to transform electric vehicles from this unreliable load into a reliable, dispatchable, and monetizable asset. And I think the three words are very important, right? Reliable, because to be used as an asset on the grid, you need to understand when it's going to be there, when it's not going to be there, and what's going to be the best use you can do with that asset. Dispatchable, because we have the ability to control the charge and discharge rate of those vehicles on a second-by-second basis. And monetizable, because we have virtual power plant capabilities that are allowing us to participate into a wide range of markets. So that helps stabilize the grid. It enables a high level of renewable penetration, because rather than adding storage on a cost basis, on a fixed cost basis, we are really adding storage on a variable cost basis. And by supporting both further renewable and stabilization of the grid, we can then share some of that revenue with the vehicle owners, and therefore encouraging the adoption of electric vehicles. Now, obviously, there are two things that you have to do very well. One is to make sure the vehicle is ready for the driver when the driver needs it, because that's the primary purpose of the vehicle, right? This is always the number one priority. And the other thing is you have a battery inside that's not our battery, and you need to make sure that you're optimizing and protecting the battery that's inside the vehicle. And that goes in determining certain criteria, such the ability of determining what battery is inside each vehicle, and then also to determine what are the characteristics, where is the most resilient area of that battery, and to keep using it in that most resilient area. So it's really encompassing all those things that is the definition of V2G for me.
Thank you very much, Gregory. So looking at what you're doing, I really like this: reliable, dispatchable, and monetizable. I think that's a very good credo. What would you say is your company's greatest success? What are you proud of that you've done until now?
I think that the difficulty in what we are doing is the complexity of the ecosystem that you have to deal with, right? You have to deal with the vehicle OEMs, you have to deal with the charging station manufacturers, you have to deal with regulators, with utilities, system operators. So there's a very complex ecosystem around, and you really need to align things, to align everybody in order to then have a commercial operation. We at Kempton started commercial operation in PJM, so participating to the frequency regulation market in PJM in 2009. At the time, it was piggybacking on a 1 megawatt battery, because you need at least 1 megawatt. Now we've been also running more than 4 years of commercial operation in Denmark with multiple type of fleets, all light duty fleets. And we're expanding that across Europe, also with our partnership that we have with EDF through our joint venture Drive, that's covering France, UK, Italy, Belgium, and Germany. And then here in the US, we see this great for especially medium heavy duty integration, where right now across the US, there's a really big push for electrification of school buses. And so we are very much involved with that. And I think, this is solving multiple problems at the same time, right? Is how do you integrate all those buses in a cost-effective way? And how do you create also transportation that is a lot cleaner for the kids at the same time?
Thank you very much. We'll get back to you. We also are getting questions from the participants. Don't hesitate to shoot your questions over to IRENA as we talk. We will try to answer some of them and put them forward to the participants. If we don't get to all of them, please forgive us. As you heard, there's more than 2,000 people online, so probably we won't get through all of it. Let me turn now to Sandra. So Sandra, you basically provide a smart energy management platform that can act as a virtual power plant and do many other exciting things. Can you tell us a bit more about that, how that exactly functions?
Yes, so hello to everybody. My name is Sandra Jettin. I'm one of the co-founders and today responsible for the business development sales of Tico Energy Solutions. And as you were mentioning already, we have created a platform to connect any kind of electrical device, which can be everything from an electrical car charger to a battery to a solar inverter, but also including more devices in the field of heating and cooling. So it could be heat pumps, direct heaters, air conditioners, down to pool pumps. And what is the purpose? The purpose is, in the end, exactly what Gregory from Nuve was telling before, just that we are not doing it with the electric car only, but we take all the different kind of appliances and devices to provide different kind of flexibility services. We do that on transmission grid level, we do that on distribution grid level, but also on the self-consumption scheme within a home or on a microgrid community level. So there are quite different applications.
So you can basically help Bastian, who's having a peak load increase of 40% over the next few years.
Exactly. And the good thing with Tico is that we can help him as well with some electrical heating that we know by chance that is quite common in older apartments in Hamburg, but also in other areas in Germany and all over Europe.
So this is not a theoretical construct. This is something that's working. What are you most proud of, and what's your biggest success as a company?
So our biggest success so far is that we have connected now over 40,000 assets, which we are controlling, and we are in different countries within Europe. So, for example, Germany, and Switzerland, and Austria, France, Belgium, where we bid on different kind of markets. As mentioned, in France, for example, on the transmission grid, as well in Germany, in other countries, it's for different kind of purposes. And now the latest achievement is that we also went to Australia, also providing our services there with aggregating different kind of assets. In Australia, it's more about battery, it's more about solar, but also a lot of pool pumps, which we have not as many here in Europe, and providing then flexibility to grids.
Right. Well, that's really interesting. And looking at, let's say, what is the biggest challenge? You say 40,000 assets. That sounds impressive, but we also know that the hills are very steep now. We need to go to 50% electrification.
Exactly.
Hundreds of gigawatts of variable capacity needs to be integrated, and we need to connect 40 million electric cars. What are the biggest challenges ahead for you?
So interestingly, the challenges are not on the technical side. You see, from technology perspective, everything is possible so far. It might take a bit of time, it might take a bit of money, but this amount of devices is not too difficult to handle. For sure, it has its challenges, but it's feasible. Right now, the challenges are more in different kind of areas, especially on the distribution grid level, which is on one side, the monetization of the flexibility, because in comparison to the transmission grid level, where you have market systematics, there is no market on the DSO levels. So as an aggregator, you never know on how much your flexibility will be worth it. It's normally one-to-one contracts up to now that are pursued. We see different kind of projects popping up all over Europe, but it's still early stages. Then the second thing is as well, and this is great to hear from Stromnetz Hamburg, it has to be a rethinking of not putting more and more copper into the field, but instead using the digitalization and intelligent management to react on the capacity constraints that are now built by electric cars. So, and thirdly, there is one last point. We should never forget about the owner of the flexibility, because if we talk about distribution grid level, it's normally the single household, it's probably apartment buildings, it's probably small commercial companies. They own their flexibility and they will not give it for free. And as Nuwe was also saying, or Gregory from Nuwe was saying, we have to give something back to the customer, and he has to get either a financial reward or some functionality reward, some improvements on his own energy efficiency. And I think we have to put here really the customer in the focus.
Thank you very much, Sandra. Very interesting. So we've received a few questions from the listeners and watchers out there. Gregory, maybe I'd like to start with one for you. There's a participant who's asking, how can policies ensure end users are given the means to participate with their EV and not locked in with a non-future-proof infrastructure? For example, monodirectional chargers that prevent prosumers to provide V2G.
So our vision is really that, there's another question relating to that, right? Starting with fleets gives us the ability to have a set of vehicles that have a more certain schedule. And that's creating a great baseline capacity that we can provide across a wide range of market. And still yet, from a vehicle per vehicle basis, we need to establish what is the probability of a vehicle to be connected at any time during the day. And that drives you into, okay, what is the best use of that, right? If you want to do, for example, demand charge management, you need to make sure that if there is a peak event on the site, you make sure that you're going to have something that's going to be able to allow you to cut that peak before it happens. Whereas when you do frequency regulation, you have a much larger area that you can play with, and you're not always called to the full capacity. And so there you have a lot more room to play with vehicles that have maybe a little bit less certainty in order to be able to provide those grid services. And then as you bring more and more variability in those vehicles, you need more flexibility in how you can play with all of them, right? Keep in mind that when you have the rush hour in the morning in normal times, not in COVID times, right? It's like maybe 20 to 25% of the vehicles that are on the road at the same time. So that means 75% of all the other vehicles are still parked at that time. So the idea of a diversity of the type of resources you're dealing with, and vehicles can really offer you that diversity. So having this diversity is the way you're able to making sure you're fulfilling the commitments. So you first establish your commitments, and then that gives you the ability to fulfill them as well. Obviously, the first step is very important, right? And how you do that, obviously, is a very important point.
So if you could sort of boil your view down to a simple ask for policymakers, what would it be that you would want from them to do to adjust the system to make it easier?
I think there's a lot of interconnection process is a very important step. There is a lot of standards that are coming together, but still, right, having a fast process to do the interconnection, optimized process to do the interconnection is important. I think, solar systems are the proof that this is, somewhat feasible. And so the ability of connecting bidirectional charging stations, knowing that those charging stations are and should be very tied to the health of the network in the area where it's connected. And I think this is where it's benefiting to everybody. And the ability, as also Sandra pointed out, is the ability of limiting the amount of infrastructure that needs to be rolled out in order to support the integration of electric vehicles. My concern there is, as we're going to start to hit the inflection point in the adoption of electric vehicles, that this rapid acceleration in terms of EV penetration will make potentially the cost of energy unaffordable. And therefore would become a bottleneck to the adoption of electric vehicles, which we'll know from a climate change perspective is a very, very important step. And so facilitating the integration of the EVs at the interconnection level, I think, is a very essential process.
Thank you very much. your point about the infrastructure build out and to what extent we limit that is perhaps a good segue to move back to Bastian. There's a few questions for you as well, coming from the audience. One of them is, do you have any incentive to invest in non-wire alternatives rather than in the transformer, the trenches, cables that go into your regulated asset base? This is an interesting one.
Actually, there is no regulation system for invest in digitalization. So we do it by our own. But as I said before, it's very easier for us to invest in digital systems than in cables or in lines, because it don't take so much time, it don't have so much invest costs and so on. Of course, we get these assets in the regulated asset base and we earn money. But we have this negative influences by long-time construction sites, and we socialize all these costs. And I don't think that it is the correct way, because we have to find a solution for a completely optimum for all these costs. And it could not be the solution to only build copper or alu. We have to combine it. And I think a solution could be to bring distribution system operators together with companies like Nuvi or Tyco, because they have the direct contact to the customer. And we as a distribution system operator has the physical infrastructure, and both should be worked together in the future.
So if you were to sort of advise the regulator on how to adjust tariffs and you can now wish whatever you want, what would that be? Would it be just continue as business as usual, or what would be the most important change in the way that the tariffs are structured right now?
I think, as I said, the peak load would be one of the most problems in the future. So peak loads have to be more expensive than normal consumption. This would be one of the operate modes to change, I think. The other one is that the regulator has to bring these digital solutions also in the regulated asset base, than the standard assets like cables, lines, transformers, and so on.
That's a very interesting one. Here's a question for all the participants, which is what assumption for private car ownership globally by 2030? Is there a target year when it will go to zero and be substituted by mass transportation, shared or clean car services? That's almost philosophical, but Gregory, just an assessment from you. Do you have a viewpoint on this?
I'm sorry, can you say it again? The quality was not going through. I'm sorry about that.
No problem. It's basically, is there an assumption for when private car ownership globally how that would look by 2030? Is there a target year, or would there be a year where it would go to zero? I think the implication is, do you expect to see a major shift in the ownership model for cars?
Yeah. So, you know, as an entrepreneur, you try to keep on controlling the parameters you can control, and then try to be flexible on the other side. So it's really hard to see, you know, how fast the ownership model is going to change. One thing is sure is, you know, there is a reason why we're starting with fleets, is because we think in general fleets are a great fit for what we are doing. The other thing we see is a drastic acceleration in terms of electric vehicle penetration in the second half of 2021, as it relates to the full chain of ownership. You know, I'm not fully convinced that we're going to go everything into, like, you know, a vehicle as a transportation as a service for each and every vehicle. So to answer your question, I don't have an answer. I think autonomous driving will be a very important aspect to resolve that problem, because that's really at the time where the vehicles could come around and pick you up whenever you need them. So I'm sorry to not give you a clear answer on that, but that's at least from the way I approach the business, that's really the way I'm looking at it. I don't want to be on one side or the other side.
No, there's a Danish philosopher who said it's very difficult to predict, especially about the future, and I think we can all subscribe to that.
Yeah.
Katie, we've been discussing a little bit some of the regulatory signals that we have in Europe and the wish list for what could change. We've heard about having a better, let's say, time of use signal, so that there's a clear sort of signal that helps us avoid peak load. We've heard ideas about being better at integrating digital assets into the regulated asset base, as an example. We've heard about other things that could help basically drive this forward. If you had a free go at just having 3 wishes to your government, what would those be?
That's a great question. I think seeing more of the commitments like we've seen from California on sales of electric vehicles is important. I think one of the things that's really important for us, and it was touched upon as far as interconnection times, is that we're looking at that same process that we took an interconnection of a customer solar panel from 30 days down to just 1 or 2 days. So we are looking at those similarities for electric vehicles to really shorten that interconnection time. And that will take a lot of partnership with our regulators to change some processes. And so I think to the extent that we can propose innovative ways to make things go faster, just having the regulators with us for some of those changes that aren't really the lofty goals, but are the ones that are practical and pragmatic, and definitely in the regulatory weeds, those are just as important. So I'd also say just bringing along our partners, the automakers, all the different companies that we have on this call and others, and having them involved in that regulatory process, and bringing voices other than the utilities, I think is also very, very crucial to this. So those are some of the things that are top of our mind.
Excellent. Thank you very much. So we're coming to the end of this session. We're already a bit over time. I think it was a very rich discussion. I learned a lot, I can tell all of you. And thank you also to all the people out there that put questions forward. Thank you to the participants. I'll just leave you with a few thoughts that I picked up that I found very interesting when looking at what is it that could help move this agenda forward. I heard very clearly, clear commitments is helpful for the business to know where things are going. I heard that also very encouraging that the challenges are not necessarily on the technical side. It's not a technical barrier that's in front of us. It's really about making this work between a lot of players in the ecosystem. It's about making the monetization of flexibility and those other services work better. And then it's basically about having a practical and solution-oriented dialogue with the regulators, looking at some of those issues, what goes into the regulated asset base, how can we make those investments, how do we avoid, let's say, investing in a lot of physical assets when we can do it digitally. So those would just be my few cents on the basis of this very interesting discussion. Thank you very much, and over to back to IRENA headquarters.
Thank you, Kristen, and thank you, Kristen, and our distinguished speakers for another fruitful discussion. We heard 2 DSOs, perspective from Germany and California, and we got the fuller picture through the complemented demand-side application perspective on their challenges and successes related to grid integration and flexibility. Thank you very much. And now we will take a short break to prepare our next panelist. Stay tuned to what comes next after the break. We will dive deeper into TSO perspective and bringing all various actors together to discuss new power sector dynamics characterized by a large number and type of actors in our last panel. We will be back in 5 minutes, so by 6:30. Thank you. Well, welcome back to our second session of the IRENA Innovation Week. We are now going slowly to the third panel discussion, which will look at the smart electrification through the TSO viewpoint. It is my pleasure to introduce you to our next moderator, Ms. Morela Constantinescu, Manager of Research and Innovation in the European Network of Transmission System Operators for Electricity, or ENSOE. Norella, please, floor is yours.
Thank you very much. Thank you very much to IRENA and EPRI for organizing this interesting exchange, a webinar on electrification. So we saw before this session the DSO perspective. Now we are going to look into the smart electrification at DSO level. And of course, we have here two dimensions. On the supply side, of course, we have the connection of especially big wind power, and on the demand side, of course, we have the connection of industry. So how the industry can be electrified directly, but also indirectly. And when I talk indirectly, of course, I would like to mention the power to hydrogen and the electrolyzers. So I would like to introduce you to our panel, which is formed of Anders Hansen, the chief engineer at Energinet, which is the transmission system operators for electricity and gas in Denmark. So we will have with him the European perspective on the electrification strategy. And then we will follow with another utility. So having Pablo Mosto, the planning and environmental manager with the Uruguay National Electric Utility. Then we will have in the panel Christopher Greiner, the Chief Technology Officer of Energinet. So we will have the a little bit the technology point of view into the smart electrification at industry level, as well as Adele Lider-Dale, which is the hydrogen project manager with the European Marine Energy Center. So having said that, I would like that actually the panelists are showing on their cameras. And I would like to start with the Anders. Anders, you are Chief Energy Engineer at Energinet. And of course, in Europe, I think Denmark, it's the country which it's a front runner in wind developments. So especially including the offshore wind, where we have actually big ambitions in Europe. But also, of course, this wind has to be integrated. So the first question for you is which is the Energinet strategy for the electrification and for the integration of this huge quantity of wind energy, especially?
Thank you, Norela, for the introduction. And do you want me to present the slides now in a few minutes and come to your questions during that? I can do that.
Yeah, please go ahead.
Yeah, okay, thank you. As you know, Denmark is situated close to the North Sea at the northwest part of Europe, and the North Sea is really a huge resource for offshore wind power. So there's a lot of visions out there how to harvest these enormous wind power resources. As shown here in the left part, there's a lot of work looking at hubs where you connect the offshore wind power and you connect these hubs to the countries around them electrically, and even investigated to do it by hydrogen. If you zoom a little into Denmark, there's a huge demand for much more electricity. We have almost 50% of wind power in the power system today, but we need even much more because we have an ambitious target of 70% climate gas reduction towards 2030. So we need much more electricity for heat, individual heat pumps and district heating heat pumps. And we also need much more heat for industrial heat pumps. We need much electricity for industrial heat pumps and much more electricity for electric vehicles. We expect up to 25, maybe 30% of electric vehicles of the fleet in 2030. And finally, there's much more electricity demand for power to X, where we produce hydrogen, and this hydrogen could be used further for production of fuels for heavy transport, aviation, ships, but also to be used for ammonia production and even be used directly as hydrogen. So much more wind power is needed, and that comes to give us much more imbalance in the system. So please take the next slide. In the next slide, you can see the upper left corner, it's a 2035 case study, the hourly imbalances shown in blue. So they're really huge, these imbalances. So that's where it's so essential to have the flexibility from electric vehicles and from the heat pumps to have this hourly and daily imbalances. But what we also can see in this is that there's a seasonal variation and demand for more seasonal storage. So we need not to cope only with electric vehicles. We also need to have storage that's cheaper than battery storage, something like heat storage or even hydrogen storage in caverns. So in the left corner down there, you can see the cost, the unit cost for storage capacity. So if you go to seasonal storage, hydrogen is so essential. And that sums up to what you see in the right corner here. We want to look into this hub and islands where you interconnect to large consumption centers shown in squares, where you have this power to X, where you have hydrogen, and you even connect this hydrogen as shown in blue with pipelines to large caverns. Summing up, the essential is that if we use the flexibility from all these electric vehicles and the heat pumps and combine it with the flexibility from power to X and hydrogen storage, we think it's possible to balance this 100% renewable-based system within a decade. So I think that's conclude my presentation.
Thank you very much, Anders. I will come back to you about these developments regarding interconnection, also the use of hydrogen, so more related to your first slide. I will go now to Pablo Mosto, so to see also the experience in Uruguay, where you have also huge deployment of wind energy, and how this is integrated into the system, into the power system, and how you manage the balancing and ancillary services. Pablo, to you.
Okay. Thank you, Norella. Thank you, IRENA, for this possibility to participate in this Innovation Week. Just to help my point in this presentation, the presented country is a relatively small country, Uruguay, only 3.5 million inhabitants, but with a very notable change in the energy matrix of the production of electricity that nowadays reach about 98% in a year of renewables, considering hydro, wind, biomass, and solar. But this is not only a matter of energy production, but also it's a dramatic change in the siting of these new resources. Before 2010, the country had already installed about 2,100 megawatts, and between 2010 and 2017, an additional 2,200 megawatts of renewables had added to the system. This introduced a very high change and effect in the grids. Please, the next. If you see on the one hand is the previous system, previous at 2010, and on the right is the actual one. That you can see that it's not only a matter of the total amount of energy or megawatts, also is an important change in the location of all that resources. And for the transmission system, especially, this introduced new challenges on how to operate and how to deal with these flows of power in the grid. And please, the last one.
Next slide.
And then the two different ways to deal with these new challenges in the grid is first of all to introduce or continue introducing more technology in the operation. That means devices like automatic reconfiguration systems, or also dynamic capacity meters on the congested lines in order to manage in the optimal way the capacity already installed. And also, another way is to complement the company business model with some reconfiguration of the market in order to give better comfort signals for a better comfort for households, or competitivity for productive sectors, or to attract new investments because of, for example, the energy price levels, in average, that go down with this introduction of renewables, but also to strengthen rules for the international interchanges with our neighboring countries, because that also is a very well alternative to an economic justification of the change and the change towards this big amount of renewable. This is my initial, let's say, overall view of the electric sector and how the main lines of action are structured.
Thank you very much, Pablo. So we will come back to a second round of questions. Now I would like to go to Christopher. So you are a technology provider, and from your perspective, so from your point of view, how do you see actually the technology which will help especially the industrial applications to maybe move towards the electrification? Which would be the scale, and which are the competitive industries you see around you?
Yes, thank you. Maybe you could also move, yes, to the slide, thank you. So I would like to just start by introducing the case and also Organised, which is probably a company that is quite new to most people. So what I'm going to talk about today is electrification of industrial process steam. And why is this important? Well, it's because steam systems are part of almost every major industrial process. And it's estimated to account for almost 40% of the global final manufacturing energy use, or almost 10% of global final energy consumption. So the way we see it, steam systems will have to electrify in one way or the other. Now, Organised is a technology company. We're based in Europe. We have our headquarters in Norway and offices in Germany and in Spain. We are rolling out a novel energy storage that we call thermal batteries. Thermal batteries store energy at high temperature in a low-cost concrete-based material. And we can store anything from a few megawatt hours to several gigawatt hours. The thermal battery will basically convert electric energy from the grid into heat at up to 400 degrees Celsius, store that heat, and then dispatch it as steam according to the customer need. And the overall energy efficiency of that process is more than 90%. So you can basically view our system as an electric boiler with multiple hours of integrated storage capacity. Now, Energinest broke the market last year. We are currently executing 2 commercial projects, one with a major Italian oil and gas company, and the second with one of the world's largest chemical companies, fertilizer manufacturer. And our solution is applicable in all types of industries, spanning from metals, chemicals, down to pulp and paper, textiles, food and beverages, and more. And we're already seeing customer pull in several of these market segments. I wanted to also illustrate how things could look like. So on the slide there, you see an illustration of an example system for a single industrial customer. So this has a 14 megawatt electric heater, a thermal battery of approximately 3 hours of storage capacity to charge, and then an 18 megawatt steam generator. Now, if you see, like these large industrial clusters, you could foresee systems that are maybe 10 times as big as this. And such a system like this will have an operating range of close to 0% and up to 100% or more, and can respond within seconds. And the basic way to operate this system would be to bid the power consumption of the electric heater on the wholesale electricity market, so the day ahead or the intraday market, in order to capture the lowest electricity prices. And then in real time, we could provide grid services. So the key here is really to be able to produce process steam at a lower cost using electricity than what the customer pays today to produce that same steam from fossil fuels, basically. So yeah, in short, this is what Energinest is about. Thank you.
Thank you, Christopher. I will pass now to the Adele. Adele, you are going to talk about another technology, which is hydrogen. And we are looking forward to see your experience with your project you carried out on hydrogen.
That's great. Thank you for having me along, as others have said. Thank you for inviting me on to this evening. So I have had the pleasure of working particularly on this big hit project for the last 3 years. I'm up here in the Orkney Islands, so for those of you who don't know, you can Google it later. We're at the very top end of the Scottish Islands, and we ourselves are made up of a group of different islands, so it's not just one landmass. There's multiple small islands which have varying populations from a few dozen to a few hundred people, and that's what you can kind of see a couple of the main islands that we've been developing these hydrogen projects on the map there. So this was really born out of an issue that we have. We have a transmission network. We are at the end of a very, very long transmission grid, basically. So we have a limited capacity to distribute power on the island. We have the active network management scheme, which is a scheme developed by the grid operator here in Orkney. And within that active network management scheme, the islands have been split up into 9 grid management zones with 8 different grid measurement sites. We are in a very great position that we have good factors for developing renewable energy, particularly onshore wind. Unfortunately, with the grid as the way it was, we call it constraint or curtailment, we quickly had a moratorium on any new connections to for particularly wind developments. So I think that came into force in 2012, and with the active network management scheme, we were able to add on extra megawatts of renewable power. So we have over 700 microscale wind developments, so personal ones, and we have about 10% of households here in Orkney, over 1,000 households generating their own renewable power in terms of solar or wind is the most common. We've got hundreds of air-to-air, water-to-air heat pumps and dozens of locally owned larger scale wind turbines, usually around the 900 kilowatt mark. We also have a really high uptake for the population. So we have a population of just over 20,000 people, and we have 268 registered electric vehicles. So with that moratorium really was where these hydrogen projects were born from. So we weren't able to add any additional capacity. We generate 120 20% of local electricity demand from renewables. So really we were stuck and we had to come up with an innovative solution. So the first project was the surf and turf project. So you can see on that little island at the top of the map, that's ED. There was a 900 kilowatt community-owned wind turbine, and EMEC, the European Marine Energy Centre, have a tidal test site there. So we were able to generate hydrogen from tidal power, which was the first in the world, which is great. So we did that using a 0.5 megawatt electrolyzer, and we also have some storage there. You'll see that we have the issue of logistics. We have to transport by sea, which in itself has not been easy. The hydrogen gets transported onto the Orkney mainland, and there we use the hydrogen to recombine back into electricity. We have a 75 kilowatt fuel cell, and that provides power to ferries while they are waiting dockside. The goals from the Surf and Turf project were expanded in the Big Hit project. So that's a multi-million-pound FCHJU funded project with 12 partners from all across Europe. We decided to add additional end use of transport and heat. So we have 30 kilowatt of catalytic hydrogen boilers installed on a second island there. We added an additional 1 megawatt of electrolysis, so that's 1.5 megawatts in total. And we also added some hydrogen vans. So they're combination vans. They are electric Kangoo vans with a fuel cell kit attached to them, which effectively extends the range. It's really interesting in terms of the vehicles that when you add that hydrogen component, you need a smaller battery. So there's been some discussion around resource use, etc. And we obviously have a hydrogen refueling station as well to be able to operate those vehicles. The interesting things really out of the Big Hit project was this. We have kind of on an accelerated timeline experienced the curtailment that some of the other partners have been talking about today. So really we couldn't generate any more, so we had to come up with innovative solutions to get around that. The electrolyzer on ED is connected to the grid, so in theory that could be used for grid balancing. The issue we've come across, mainly it's been touched upon already in this evening's discussions, is really around the legislation and the regulatory requirements that you have to adhere to, and the timescales of the projects. So we've come across a lot of kind of nuanced regulatory barriers across all of the different uses for hydrogen within the projects, really. And yeah, the main project and our main ethos in Orkney is really about demonstrating kit technology, you know, getting things working, moving things around, shaking out any problems that we might experience. And from the success of these projects, we've seen additional projects such as the Reflex one in Orkney, which is kind of what we've discussed this evening as well, around innovative kind of peer-to-peer energy trading, smart use of assets regarding electric vehicles, etc. We've been using hydrogen in the High Seas3 and the High Dime project, or we plan to use hydrogen. The maritime or shipping, as you can see from our island nature, is one of our heaviest, like carbon dense sectors in Orkney, and one that we rely on quite heavily. So we're using hydrogen to decarbonise ferries. And then some of you may have seen in the press as well over the last few weeks that we've been involved, or EMEC has been involved in the High Flyer project, looking at the first commercial flight using hydrogen technology. So it's a really quick fire introduction to our projects here in Orkney, but the main takeaways are curtailment, reducing the curtailment on the energy grid, demonstrating different demand uses for the hydrogen, and really kind of addressing a local problem in that curtailment.
So thank you very much, Adele. I think we made the round. So having the utility perspective with the TSO and both South America and Europe, and then with the two technology solutions which can offer different services either to the grid or can actually stack services for the demand and different applications on the demand, as we have seen on Adele project. I will come back now to you, Anders. So you were mentioning actually the need, of course, for certain type of services which require fast ramping ups and down, fast response, but you also mentioned the seasonal storage, actually, which mainly it's request for those energy mix where you have quite a lot of probably wind developments. And then you mentioned actually that, of course, being the TSO for electricity and for gas, so you look both at electricity development from the power grid. So, and I saw in one of the questions if this should be DC related, but as well as the hydrogen. So in this optimization effort, did you look into how actually the electricity network and maybe potentially the hydrogen network is going to develop from your perspective, so from Denmark perspective, and also the impact on the neighboring countries, looking into these two careers which can help each other? So this is the first question. And secondly, if you look at locational location requests, so in order to be able actually to support the electricity grid for flexibility requirements, but also to deliver on the applications which might be needed by the industry.
Yes, thank you, Norella. Yeah, we as a TSO for both the power and the gas system, we are obligated to do some total system analysis. So we have a model where we include potential development of the power grid and the gas grid, and the gas grid also includes using a hydrogen. So it's a system approach we use, and by this we have, of course, technical cost to see what's, if you work for least cost solution, how could that be? Of course, we need a lot of different scenarios because there's definitely uncertainties and you might not go to reach the least cost solution. But it's really a co-optimization or co-analysis of the development of the grid, the power grid and the gas grid, and potentially a hydrogen grid. And then you also asked, when it comes to the international, Denmark is a very small country, strongly connected to the surrounding countries. So part of the analysis is, of course, electrical interconnections, but we're also looking into potential delivery of hydrogen to the European continent as a possibility. So a lot of scenario studies are definitely needed. Then when it comes to the location, there's a lot of things influencing the location, because we have a lot of district heating in Denmark, and where you saw on this drawing, the squares, we expect a lot of power to X capacity. That's also where we can use excess heat from all these processes to producing district heating. So of course we electrify the heating, but we also take a lot of excess heat from the power to X industry in the scenarios towards 2030 and 2035. You had I noticed you had one question also about, was it DC or was it AC? We are building overhead lines. It's in Denmark really not popular, and I think that's the same for most countries. So we are also looking into more AC cables, but that's technical an issue to handle a lot of AC cables. So we're looking into feeding this HVDC from this hubs I showed in the North Sea into central points in the grid in Denmark.
Okay, Anders, thank you very much. I will come back and also pick up some questions from the audience. Now I will go maybe to, I will start maybe with Christopher, and then I will move to Pablo. So Christopher, you have mentioned your application actually for the I would say industry processes which probably require rather high temperatures, I suppose. So this is mainly your application. So you said that heat, at least the one you showed, heat delivered at 400 degrees. And of course, there are other sectors where you have thought about maybe applying this technology whilst having also deliveries for the grid services. My question for you would be, so which it's the potential of such a technology, because we can have, for instance, maybe hydrogen delivered to an industrial processes. So of course in Europe we think about these possibilities. So your technology and your application in comparison, for instance, with the hydrogen in the general use of for industry applications, especially for these high temperatures.
Yes, thank you. That's a very good question. You know, we're actually quite fond of this ambitious hydrogen strategy that recently came out in the EU. And we also see that the hydrogen strategy towards the industry is focusing on the very high temperatures, so above 650 degrees. And although we don't know exactly the details, having been heavily involved in this industry for a long time, I would expect this is because they see hydrogen as a substitute fuel for instance, natural gas in, for instance, metals in industry where you need very high temperatures inside furnaces. EnergyNest is focusing on maybe what you could call more like moderate temperature. So process steam systems, typically in the temperature range 150 to 350 degrees Celsius. This is covering more or less all steam demands. And as I said in the introductory statement, also process steam is part of almost every major industry. So I think that we, EnergyNest, or our solution is actually quite complementary to hydrogen. We don't see hydrogen really competing on the consumer side. Of course, we will be providing similar grid services. You know, having a flexible heater is very similar to having an electrolyzer in terms of ramping capabilities, response time, and these things. And of course, we also need access to cheap electricity. I mean, the only way you can outcompete natural gas, especially nowadays when it's unfortunately so cheap, is you need access to cheap electricity. And the key in order to do that is to have storage so that you can charge when the electricity prices are low, and then discharge that energy to your customer throughout the day when the electricity prices are much higher. I would also like to just end that with saying that the way we are marketing our solution, we're also now building up financial strength to supply fully financed solutions to our customers. So basically taking the whole investment burden off the shoulders of the customer and let the customer rather enter into having, for instance, fixed annual payments, rental fee, if you will, or a fixed price per unit of steam delivered. Arrangements which are quite common already in the energy industry. We also think that this is the way in the future. So, thank you.
Thank you, Christopher. I will go now. Thank you for actually making this assessment with the hydrogen supply. So taking into account also the temperature and actually the fact that you can also store electricity, which I think indeed it's a kind of advantage. Of course, it can be also stored in a way into the hydrogen capacities, but you gave us the picture of actually having an electrification solution for the industry. Now I go to Pablo Mosto. So Pablo, you were mentioning Uruguay. It's a small country. You have a lot of renewables. You have a lot of wind actually, and you mentioned that you have all these devices, smart grids. And all the demand response and so on coming into your picture. Of course, this session is focused more on industrial and hydrogen applications, but if you have the perspective also of how do you actually see the integration of such scale of renewables from the point of view of the interconnection with the other countries, and how you see actually the use of distributed flexibility sources in actually solving the grid needs, so the flexibility and ancillary services needs in a country like Uruguay.
Well, first of all, I'd like to remember that Uruguay is a small country, but surrounded with two very big neighbors like Brazil and Argentina. And we have historically well connections, international interconnections with both countries. In the case of Argentina, 2,000 megawatts interconnection in 500 kilovolts since the 70s, late 70s. Then is several decades of experience in interchanging energy. With Brazil, perhaps less, but we have since year 2000 and 2002 interconnection, but there is technically different interconnection because it's based on different frequencies. We have here in Uruguay or in Argentina 50 hertz, and Brazil is 60 hertz. Then we need converters, frequency converters. Then this is perhaps some differences in the operation of the interchanges, but it's a good way with both countries to consider both as a possibility of, let's say, a way of storage, because if the relations with the neighbors are mature, then there is a possibility to give energy, to sell energy when we have some surplus, and obtain energy when perhaps in other moments when we have less of wind or with less water than we expected. Then the important deal, or that I want to perhaps to talk a little about, is related with the surplus, because is in the case of having a system with wind, solar, and a lot of wind in our case, this type of surplus are not like when you have, for example, in a system a lot of backup thermal capacity that you can turn on and produce energy. In this case, you need to deal in the grid, in the transmission grid, and also related with the forms of interchange with neighbors. You need to deal with this ability of the resources, and then all the is optimal to have some ways of interchange that are also very variable, like opportunity offers, we have, for example, some possibilities to interchange with Argentina that are based on the substitution scheme. We have energy at some price. They have some possibility to turn off some source, and we try to go to the average of the prices, our price, and then both parties wins. This is a good way to interchange. With Brazil, it's slightly different because it has internal rules that make a weak offer and with a price. We need to figure how we'll operate our system the next week, and we put now a price and capacity offer for the whole next week. There are different ways, but we try in all the cases to use as much as renewables as possible.
Thank you very much, Pablo. It's still the question about the use of DC, but maybe we still come back to this. I would like now to turn to Adele. So Adele, there is actually a question which is there for you. You were mentioning that actually you have hydrogen, you have heat, you convert actually from power to hydrogen and back. Is this a kind of, how to say, these conversions, they have certain efficiencies. So how you make actually the business value of the clusters you set up in the big heat project?
Yeah, so the projects were initiated in 2016, so for this round of hydrogen developments, quite young in the industry. So really the projects were set up to kind of establish just those kind of strike prices for hydrogen, basically for different end uses. We understand in the projects that reconverting the hydrogen back to electricity is not the ideal solution, but we have a really unique set of circumstances in Orkney where we have so much wasted energy. Some of the wind turbines in Orkney are curtailed 60% of the time. So when we start to factor in, and we don't get a balance of payments, so the operators of the turbines are not paid by the network operator to turn down the turbines. So for them, there's a loss of revenue by having the wind turbines curtailed or switched off. And the use of hydrogen, then in that downtime, we then have a product in hydrogen that we can capitalize on. So we have done some calculations on the efficiencies of converting back to electricity. And yeah, they're around 50%, sometimes a little bit higher than that. And really, we managed to shake out from the big hit projects, which seems kind of like normal parlance now, that transport is definitely the kind of first avenue for commercialization. And we found with our projects that that's viable for us using the hydrogen for road vehicles. But yeah, the pricing is tricky. But we're not operating in business as usual. We still have this element of decarbonisation that we're trying to tackle. You know, and if we carried on business as usual, we wouldn't be looking at any of these solutions. So yeah, we still haven't figured out how we're going to capture the carbon, but we've got a really good carbon audit for Orkney, and we know our areas that required. So for us, use of hydrogen in transport is already commercially viable within the structure of the projects that we have now. And we actually have a power supply agreement in place with the local authority to supply them with electricity for the ferries when we're reconverting the hydrogen back. So we're starting to build up that kind of business case.
Thank you very much, Adele. Christopher, for you, there are questions regarding mainly the storage costs, including efficiencies. So from the point of view of OPEX, and CAPEX, and actually, which would be, how to say, the price. So I asked you before the competition with other systems, but in this case, which would be the competition with the heat storage system, pure heat storage system?
The competition with a pure heat storage system, I'm not sure I fully understand the question, to be honest. I think, if we're talking about competitors, are we talking about other providers of process steam as heat, or heat in general?
So heat in general, I would say.
Yeah. Well, heat is not heat. I mean, there's a big difference between, district heating, which is basically hot water, and the process steam, and then to the very high temperature, the furnace heat that you need to melt steel. So I think it's, you can't really compete or talk about these things as if they're the same. I think we should process steam is covering a very, very large part of the final energy consumption. And if you really want to fully decarbonize the industry, you have to do something about process steam. And to electrify process steam in a way that does not put additional strain on the power system, you need that load to be flexible, and to do that you need some sort of energy storage, and we have a solution for that. The competitor landscape is quite small, actually. I mean, there's only maybe a handful of companies on the global market as of now with competing solutions. Most of these are in a less mature stage. We are already commercially available and are also executing commercial projects. Also, I think the size of this market is so gigantic that even if there's lots of competitors out there, there's no single competitor that's going to be able to saturate this market for a very long time. And as you also asked this important question on how do we compare to hydrogen, as I also said, I mean, we are complementary to hydrogen in the fact that they are not focusing on process steam systems. I think it's also very important to again state the efficiency part. So converting electricity to heat is virtually 1-to-1 on efficiency, taking into account all the of course, the inevitable losses that you have in power transformation, heat losses in various parts of our system. We are still in the more than 90% efficient. If you were to use hydrogen for the same application, you would have an efficiency of less than 60%. So clearly, from the efficiency point of view, thermal or direct thermal conversion and thermal storage would be the better option. The question about cost is difficult to answer because you need to be very clear about what cost are you talking about. Are you talking only about the storage, or are you talking about the complete system, and what does the complete system contain? So if we're talking only about the storage, which is maybe easier, ballpark cost of thermal storage that we have is maybe around 50 euros per kilowatt hour of thermal energy. So that gives you an idea of where this cost is, and at least a rough way to compare to other solutions.
Thank you very much, Christopher, for being also open, including to the cost question. Now, in 1 minute, to both Anders and Pablo. Of course, the integration of renewables means a lot of inverters, so the connection of the inverters. And here we will move to the question about how to use actually the DC lines in order to also cope with this challenge. But very briefly, 1 minute, Anders, 1 minute, Pablo.
Okay, yeah. With the HVDC lines, it gives us really the opportunity to go into central load points. But we're also looking into a future with much more inverter-based resources. We don't have so many conventional plants running. So what we really need to learn also as TSO is driving a stable system based on inverters. So that's a new challenge and needs new type of ancillary services. So that's gives us good possibilities with this HVDC solutions, really, but we need to learn more about operating a purely inverter-based system.
Thank you, Anders.
In my case, I think that I can answer in less than 1 minute, because Uruguay is, as it's a relatively small country, there is no experience on HVDC lines. And then also all this development of wind energy is on the territory, on land, not in the sea. Then also we are not entering yet in this type of DC lines. Then for us, till now is a thing to think about, but in the really future, but not in the proximate years.
Thank you very much, Anders and Pablo. So I would like maybe to conclude this session. Thank you also the audience for the questions you raised. What I take, my takes, I don't know if it's also yours, is that from the perspective of transmission system operators or the utility as it is in Uruguay, so we will be actually integrating a lot of resources, renewable energy sources, especially in Europe, because we have the political drive, and in Uruguay you have that experience as such. To go forward, of course, it's important to have a kind of integrated approach when we look at different infrastructures, being electricity in the case of Denmark, but also having the look on the impact and the potential optimization and potential provision of flexibility sources from other networks like the hydrogen. Of course, there are also, from the point of view of the locations of these electrolyzers in the system, we have to look both at the energy mix, the infrastructures, but also what we have at local level, such as district heating applications. In the case of Uruguay, we have seen that actually this is mainly based on the interconnection with the countries, so with the neighboring countries, which is the major takeaway, and also developing of business models which help actually business models and markets, I would say, in order to integrate more renewables. Of course, we have a lot of inverters in this world, which we have to work with and to take actually the opportunities which it's offered. So this is related to HVDC development. On the demand side, we have seen very interesting applications from the two solutions providers. So going actually in industrial applications, what I take from you, Christopher, is to look at the efficiencies first, the temperature levels, and not all the technologies actually will will be the best for the different applications. So when we look at the efficiencies when transforming from electricity to hydrogen and then actually providing the supply is not the same as using electricity directly, and this is of course a straightforward message. And of course we have to look at these applications when we have high temperatures. And from Adele, so the cluster you have mentioned with the hydrogen heat applications, what I would take is that of course in the transport sector you mentioned the ferries, but also other means where maybe the electricity cannot be as such directly used. This is a way forward for this type of application of hydrogen. So I thank you very much for your inputs, for these exchanges, and I give back to IRENA.
Thank you, Norella, and our distinguished speakers for their experience on a great exchange on innovative way to address various challenges at the TSO level. We heard from 2 TSOs, and their views were again complemented by 2 demand-side perspectives. Again, thank you all for sharing with us all your experience and visions. Our last panel discussion will bring together all power sector actors, and we will explore what else can be accomplished at TSO and DSO level, and how to share flexibility resources more efficiently. It is my pleasure to introduce you to the moderator of our last session, Mr. Robert Chapman, a Vice President of Electrification and Sustainable Energy Strategy at EPRI, which is our partner organization for this session. Robert, over to you.
Great, thank you, and appreciate the dialogue thus far in the workshop, been very informative. And I look at our closing session as being an opportunity for us, as we say in the U.S., for the rubber to meet the road per se. And by that I mean that when you look at where the power system transition is evolving to, it is so critical that we begin to integrate the supply with the transmission, with the distribution, and with customer choice, and we integrate that in a seamless fashion going forward. Each one plays a critical role to make sure that we are able to provide affordable, efficient, and sustainable electricity to those that are relying upon it in terms of economic benefit as well as safety and health benefit. So in this particular session, we are going to bring together the various panelists that have presented already. In the interest of time, so that we can make sure that we get to questions, I'm not going to reintroduce the panelists who have already presented. We may have lost Katie Sloan. Katie is here in California, and I also experienced some technical difficulties. Katie has dropped off, so we may not have the benefit of hearing from Katie again, but we will have the benefit of hearing from Bastian, Anders, and Pablo in terms of the opportunities and challenges that they see. And I'm going to start off with the group by just introducing a concept that has come up in the chat throughout the session, and really to capture your feedback. And Anders, I'm going to start with you and then go to Bastian, and then Pablo, I'll close with you, since that you are a vertically integrated utility, and it sounds like maybe we do have Katie back on, so we'll include Katie also. But the question comes around regulatory construct. Obviously, decarbonization is a big driver behind what we are doing and the changes that we're seeing in the power system. The question for you really is, how do you see regulation taking a more proactive role in helping to drive change in the power system so that we can achieve our outcomes in a more timely fashion? Anders, let me start with you from a TSO perspective.
Yes, I think we're looking at a lot of need for integration from the distributed resources at the distribution level. So regulation that gives us good opportunity to use this flexibility in a way that it could be used efficiently for the distribution grid, but at the same time really could be used to balance the TSO grid in hourly level, primarily when it comes to this distribution of resources. So TSO, DSO integration is so essential to cope. Just to give an example, when you look into 2030 in Denmark with expected number of electric vehicles, it's a charging capacity larger than our whole power plant capacity. So it's really a muscle we got out there, and we need to control it efficiently. So that's essential one. Then another essential one is also regulation when it comes to this power to X and integration with hydrogen. That's two sectors coupling. So there is barriers that to work on. So really have this efficient sector coupling. I think that's also so essential. So I think I will highlight this as some of the most essential regulating barriers.
That's great. Thanks, Anders. And Bastian, just to build off of what Anders talked about there from a regulatory perspective or regulation perspective, the importance of DSOs and TSOs working very closely together as the power system evolves. Maybe say a little bit from your perspective about the importance of that and any insights that you have in terms of how regulators can continue to advance that. Bastian, are you on?
Yes, I hope you can hear me.
Yes, can hear you. Yes.
I want to agree with Anders. The sector coupling is very important for us as a DSO too. And I think there are lots of barriers to solve about the regulation, especially when you produce electric power from hydrogen. When you make the hydrogen from the electric power, it's not so much a problem than in the other direction. And I think we have to solve it to couple both systems in an efficient way. And of course, it's absolutely important that the TSO and the DSO working close together. We implemented lots of systems that DSOs and TSOs plan together the next 2 days, the next 48 hours. It's called Redispatch 2.0 in Germany. And so every flexibility in the next 2 days will be planned together, so both DSO and TSO can participate from the system. And in my opinion, the DSO is the more flexible system because it is nearer at the customer. So when we talk about using flexibility, as I presented a few minutes ago in the panel too, we talk about reaction times from 1 minute. And I think it's very fast to react to critical situations in the grid. And the time between DSO and TSO to react to critical situations is a little bit longer because the system is not so flexible between both of them, but it's absolutely necessary that both of them plan the next days and the next hours together.
Yeah, great comments. I appreciate those, Bastian, especially the note that one, that you have a planning session between TSO and DSO coming up, how important that is to integrate activities. I know it's something in the US that we're very interested in. And I especially enjoyed your comment around the DSO, of course, and the role that they play with the customer and having more flexibility with that and having that more near-term touch and more timely touch. Pablo, let me turn that question to you. You have the unique perspective of being a vertically integrated utility in Uruguay. And you also mentioned in your remarks, of course, the extensive hydro and wind that you have from a renewables perspective. But let me just ask you from a regulatory perspective, what do you see as kind of key aspects that the regulatory framework can overlay to help drive you forward in terms of meeting the decarbonization challenges that we are focused on? Pablo?
Well, as you said, we are a vertically integrated utility, but also we are a state-owned utility, a state-owned company. Then with these two issues, we think that we are in in a very optimal position to integrate the view of these dynamic end users sectors and needs with also the government directives, guidelines. Because, for example, when this important change in the energy production matrix of the country included in 7 years the same amount of wind power like in the whole history of hydro, then it's very important for us this situation. And what are the drivers to do so? Well, one of the drivers is because as a state-owned company, we work together with the government in this case, and we took the guidelines of the government, but transformed the guidelines, making the bidding processes and also signing the contracts, the long-term contracts. Because if not, the financial entities are not going to bring money to these projects. There are no company with enough back to respond over 20 years or 30 years for these payments. Then for us it's very important in our view to maintain, if possible, this activity of my company, UTE, but also now with another perspective. Because if we already changed the energy production matrix, we are now in front of the end use of this energy, and how this energy with a low marginal cost, near zero, can be used. And the important thing, the regulatory aspect on this point, is that we need to remember that to have a near zero marginal cost in some important periods in a year doesn't mean that the overall cost of the energy is zero. I'm saying that because the end users, especially the big ones, that are, for example, nowadays in the regulated market, have a signal, if only see the marginal cost of the system, to quit the regulated world and go to the as a free consumers. And then this type of free consumers, because they see that the marginal cost is better, is lower than to pay a tariff, then these signals from the regulatory perspective need to be controlled in order not to introduce artificial competitivity, because perhaps we not consider, as an example, in this case, if big end users turn from the regulated world to the free consumers world, then they are not continuing paying the percentage of the long-term IPPs contracts, and then the remaining consumers in the regulated sector going to pay a little bit more. The previous part and the part that these consumers that go to the free market are living without paying. Then it's a vicious circle that the regulation of the countries need to be well prepared, and with these smart grids are increasing the opportunities to or try to do the business in several ways. Because of that, we think that it's very important as a vertically integrated and state-owned company to maintain a close relationship with the regulator.
Yeah, it's a great point, Pablo, and very important for the entire group, of course, to recognize, well, the marginal cost of the fuel, supply fuel may be zero, the marginal cost of delivery in the grid is not zero, and very important to inform regulators and others to make sure that they recognize that as we try to identify value streams and maintain affordability. Let me see if Katie Sloan, Katie, were you able to rejoin us? Doesn't sound like
Rob,
Katie
I'm
was.
here. Can you hear me?
Oh, yes, we can, Katie. Great to have you on, and appreciate you being available. I just wanted to pick up on one of the comments that was made as we were talking about this integration of supply, transmission, distribution, and ultimately customer choice. You play kind of the unique role in California as a DSO, as well as then, of course, managing the customers and supporting them. And the question was around how can regulation lead? And I think in California, you've had some recent examples of that with the executive order coming from the California governor. Maybe just touch on your perspective of how regulation can lead to help drive a decarbonized energy system broadly across society. Thoughts on that, Katie?
Hey, thanks for that question, Rob, and sorry I'm not on video right now. But I think regulation is 100% key in this transformation. And without comprehensive regulation, we won't be able to make the transition. I think, picking up on the theme of learning from what was done with renewables, what we saw that was successful in California is that we took a yes and approach. We had the high-level renewable portfolio standard goals, we had tariffs, we had both distributed and large-scale renewables, in addition to making processes faster and cheaper. And I think that we really need to, in all of the different sectors that we're talking about, all of the different electrification opportunities, take that yes and approach and make sure that we're not just focusing on one thing, but focusing on all of the things, which means we have a lot of plates spinning in the air. But I think with our collective knowledge and experience, we can all do that.
That's great, Katie. Thank you. I'm going to transition a little bit for this group because it's a question that has come up that I think is very important that we address as part of the session. And of course, it talks about our primary objective as an industry is to decarbonize the electricity sector and then enable other sectors of the economy like transportation, buildings, and industry and to support them in their decarbonization efforts. So a completely different role from what utilities may have played in the past, and an exciting role for us. But the question gets around the fact that we are creating a greater dependence on electricity. In fact, when some of the panelists spoke earlier, they talked about currently, globally, maybe about 20% of our final energy is electricity, and expectations are over the next 30 years to more than double that to 50% or more final energy being electricity. So creating a greater dependence on electricity, great. It should be more efficient, more affordable, and more sustainable, but it's also got to be more resilient. And one of the questions that has come up is, in this system, and it includes supply, transmission, distribution, and then ultimately the customer choice, how do we address the resiliency challenge that we see with the impacts from climate vulnerabilities today? So regardless of what we are doing on the decarbonization side, we have climate vulnerabilities that we are managing to today. How do you see that your role in terms of being able to support resiliency going forward? And Anders, let me start with you because you mentioned long-term storage and hydrogen or seasonal storage, but would like your perspective from a TSO. Any challenges you see with existing climate vulnerabilities beginning to emerge and what you're doing to manage resiliency going forward? Anders?
Yes, I agree very much that the resilience is very essential, and we definitely looking much into the coming decades with much more wind power and much more inverter-based resources changes totally the dynamics of the system. We also need to better be able to restart our system also from large offshore wind parks, because we have less traditional power plants running. So it's really a changed system. So that's one thing. But we also got very much information systems, so we are better to understand the real-time estimation of the system state. So it gives us new opportunities with digital solutions as well. Then the third leg that is very essential is we also have very much distributed resources.
Anders, I'm going to apologize. I have lost, I'm going to ask the group if they can hear me. I have lost video, and I don't know if I have lost sound also. I cannot hear any of our panelists. Can anyone?
We can hear you.
I can hear you, Rob, but I lost Anders as well.
Yes,
okay.
I can hear you too.
Okay, am I back now?
Yes, you are back, Anders. Thank you.
So just a very short recap of my comments was as we're looking into this inverter-based resources, and to keep resilience, we really need to look at how do we operate this stable, because we don't have so much more traditional power plants. So we need to be able to restart our system from large offshore wind parks. We also in another situation that we have very much distributed resources. Even solar is very popular in Denmark. So we got distributed resources being able to actually feed in from every corner of the system. So, and if you combine this with digitalization, I think we can keep the resiliency, but it's really a lot of new challenges to cope with, but also a number of new possibilities.
Yeah, that's great. Thanks, Anders. And I'm going to build upon that because you mentioned what I'll call digitalization and the predictive maintenance, being able to understand system performance and proactively respond to that. Bastian, you also mentioned that in your remarks earlier. Maybe just talk a little bit about what you're doing in that particular area as it relates to helping to support reliability and resiliency.
Yes, I will also agree with Anders. The complete system gets more and more dynamic, as well as the supply side, as well as the customer side, as well as the transportation. So we need more and more communication between the actors. We need more communication between DSO and TSO. We need the communication between the DSO and the customers. And the digitalization is a great chance to make these processes more and more automatically, because it's not able to do it manually. When you remember, we have more than 1 million customers in Hamburg, and when we want to control the complete system, it's not able to talk to everybody of this over 1 million customers. It has to be an automatically system that reacts on dynamic processes, as well as the TSO side, as well as the customer side. And so we need more and more communication between all actors. Actually, we have, I think in Germany, very, very good resilience. Last year we had 12 minutes blackout for each customer in Germany. I think it is a very good value, and we try to be better than this in the future, because I'm with you, Rob. it will be more and more necessarily for us to use electricity for all the sector coupling operations. So this 12 minutes should be better in the future. And I think we can make it with the use of more digital processes and more communication between the actors.
Yeah, I completely agree, Bastian and Anders. Very important. And I'm going to go to Katie really quick, and mainly because California has experienced some of the challenges recently. Katie mentioned at the beginning on her panel that she was directly impacted, her and her family, by the fires down in Southern California. But with that, of course, the extended heat waves that California experiences and some of the drought conditions, those are some of the resiliency challenges that utilities here are facing. Katie, from your perspective, how do you think about resiliency and how are you managing that within SCE's territory?
Yeah, that's a really good question and is something that is top of mind for us. We're doing quite a few things to be prepared and to prepare our grid for resiliency, especially during wildfires. So we're doing everything from hardening our grid, we're installing overhead conductors, we're doing some really innovative aerial views with drones of our transmission and distribution system, in addition to quite a bit of vegetation management. So that is all really critical to make sure that we keep the lights on. I will say, one thing that gives me the opportunity to sleep at night is that, distribution and transmission planning is something that we've been doing as a utility for over 100 years. And, a lot of us have been. And while we're in a point of transition right now, we will be able to meet this challenge, and we'll learn from things like adding a lot of air conditioning load to our grid. So I think that we're prepared. I think there's a lot that we need to do. I think that we are changing our systems and learning and growing and meeting the challenges that we have.
Yeah, that's and I love the point of, this is our core competency from the electricity sector perspective, and to take advantage of all tools. And I think the challenge, at least in the US, that many utilities are learning is, as they have gone through deregulation, is how do we make sure that we are coordinated and closely aligned at the hip with all of these aspects, the supply, the transmission, the distribution, and the customer, to make sure that we're integrating that and maximizing the efficiency and the opportunity of the system. Pablo, let me ask you that same question, resiliency in Uruguay. I assume obviously very important for you as we all face some of the climate vulnerabilities. How are you factoring that into overall system planning and design?
We have in Uruguay not the same figure as in Germany, but it's interesting that we have almost 100% of all the consumers integrated to the main system. In Uruguay, there are no isolated electric systems. And also, we are very well integrated with our neighbors, like with Argentina. The interconnection is not only used to interchange energy, it's all the time connected. Then we are working at the same frequency and have experiencing all the same problems. If there are a major event in Argentina, then we see that in our grid. But till now, this is very useful for us. And we have also an important backup of classical, traditional thermal units. We have some combined cycles, some gas turbines that can be used for a black start in like 10-15 minutes. Then this type of capacity is used to this purpose. But you know that we see of course, as an electric utility, we are very glad to see the increase of the use of electricity in the households, and also this need to be supported with the technology incorporation in all the levels. For example, we have nowadays installed 1/6 of the meters of our customers from smart meters. Next year, we will reach 50% of smart meters connected in meters, and its bidirectional communication capabilities help a lot in detecting very fast where is a problem. For example, at the distribution system, and also detect how can the problem be solved faster.
That's wonderful, Pablo. Unfortunately, it's amazing how quickly time can go, and we are near the end of our discussion this morning, focused in on electrification and the power system in general. So I wanted to thank Pablo and Anders and Bastian and Katie for their expertise in helping us wrap up this particular session with a focus on the importance of integration of the transmission, the supply, the distribution, and the customer in order to achieve our outcomes that we are looking for. And when I talk about those outcomes, I'm going to summarize what I heard this morning using 5 Ds. Ds as in decarbonization being one of them. Obviously, our objective as an industry is decarbonize our fuel and then take that fuel and apply it to other sectors of the economy so that they can also decarbonize, whether that be transport, buildings, or industry. The second theme I heard throughout this morning's sessions focused in on decentralization. Centralized power, that particular model that for many of us over the past 100 years has been the system to which we have become accustomed to, really is beginning to fall by the wayside into a much more decentralized approach that affords greater opportunity for customer and community going forward. So in addition to decarbonization, decentralization, the third D I have is what I'll call digitalization. This is another theme that I heard throughout the panel discussions today, the importance of making sure that we are integrating the capabilities of our systems to take data, capture that data, curate it in a way that makes it meaningful, and then use analytics to help do proactive and predictive maintenance and to make sure that we are managing our system effectively and efficiently. The fourth area that I'll talk about is dependency. And dependency relates to our customers. I mentioned that we are creating a greater dependency on electricity with the transition that we are evolving within the power system, and how wonderful it will be to enable that for our end-use customers. But what's imperative for us through this dependency is to make sure that we support our customers by ensuring reliability and resiliency is realized as we continue this transformation and as we prepare for a much greater future where electricity is a much greater portion of our final energy. And the last piece I would make, the last D, so I've mentioned decarbonization, decentralization, digitalization, dependency. The last one I'm going to mention is diversity. And I'm going to take this down a couple paths for you. Diversity from a technology perspective. Technology is a key enabler of risk management. The more options we have in our technology tool bag, the better we are going to be able to support our end-use customers in enabling affordability and supporting the sustainability objectives of society at large. So technology optionality is key to risk management. Diversity of technologies, especially from a regional perspective, understanding those nuances is so key to us. The other area that I want to represent, though, in diversity that's also very important is we have an obligation as an industry to serve all socioeconomic classes of customers. And we have to be very careful that in this power system transition, and as we try to manage our cost of an evolving system, that we don't leave some lower socioeconomic groups holding the bag in terms of having to pay those costs. So we have to be very efficient from an economic perspective in the transition to make sure that we are supporting all socioeconomic classes of customers and all diverse groups that lie within those particular classes. I'm going to go ahead and pass it back to IRENA, but before I do, on behalf of EPRI, I just wanted to thank all of our panelists today and also thank all of our participants for a very enlightening and engaging workshop focused on electrification and the power system. Thank you on behalf of EPRI, and now let me pass it back to IRENA.
Thank you, Robert. Great wrap up on progress made and what lays ahead of us. Thank you and the team in EPRI for co-organizing this session with us, and we look forward to cooperating with you in the future. And again, thanks to all the distinguished speakers for fascinating discussion on and sharing with us all the experience. Allow me to make a final announcement. So if you enjoyed the discussion today, let me invite you to join our next session this week. Each day we have 2 sessions. The next one will take place tomorrow morning at 8 a.m. Central European Summertime, and we will explore green hydrogen and green synthetic fuels. And in the afternoon, we will focus on bioenergy, followed by session on Wednesday and Thursday. There is still time to register. Well, and that is all from us for today. Once again, thank you for joining us, and see you in one of our next sessions.
Thank you, folks. Bye-bye.
Bye.
Bye-bye.
Bye-bye.